developers in here? Oh, okay, let me rephrase the question. Who is not a Java developer? Anybody? Okay, that's good. So this will be spot on for most people. I want to jump right into it and talk about JavaScript core. So you guys probably know this already, but JavaScript is an interpreted and has dynamic typing. So you'll see the interpreted nature of this come out as we start doing some code examples. Okay, so bear that in mind when I start quizzing you about how JavaScript works when we run some code examples. And one thing to note, in JavaScript, objects are basically associative arrays and prototypes. So we'll look at that in a few minutes as well. And we'll also spend a little bit of time talking about functional JavaScript, i.e. first-class functions, and also touch a little bit on closures. Right? So again, we only have about an hour, so I'm going to try to cherry-pick some of the more interesting things in JavaScript. Now, most people know that JavaScript is a prototype-based language. Okay? It's object-oriented, but it's not the kind of object orientation you expect in Java. It's prototypical object orientation rather than inheritance-based or classic object orientation. There are a few other prototype-based languages, specifically IO, Lua, or Self. Okay? Now, how many people have ever used any of those three languages? IO, Lua, or Self? Anybody? Not a single person. Okay. Usually there's at least one or two people who've used Lua, which is a scripting language for C and C++. And this is, I think, where some of the confusion for prototypes in JavaScript comes from, is that there's really not another language that predated it that is used frequently, specifically IO, Lua, or Self. Right? And the basis of prototypes in JavaScript is that essentially an object has a prototype, which is, in a way, its superclass, and that is the prototype object. We'll have a quick look at that in just a second. Now, if you're interested in looking at a clean implementation of a prototype-based language, there is one covered in this book called 7 Langs in 7 Weeks, which is an excellent book, but there's a chapter, one specific chapter on IO in here, and if you're really interested in prototypes and how they work in JavaScript, IO is a great way to learn how let's say, a clean room language that is prototypical is supposed to work, because like everything else in JavaScript, it's a little bit different than what you would expect when you actually work with different features of the language, specifically prototypes. So let's spend a couple of minutes and explore prototypes. What I'm going to do is going to drop to my code editor here. Okay, can everybody read that? Can I make that smaller? All right, that should be good. All right, so what we're going to do is we're going to use a function definition called gadget to create new objects from. All right, and this gadget has a name and color. It also has a describe function contained within it. Okay? And the first thing I want to do, let me comment this out for now. So the first thing I'm going to do is I'm going to create a couple of new objects here. All right, we're going to create an iPod and an iPad instantiated from a gadget object, or a gadget template class, if you will. And we're also going to set the price and a describe function against the prototype. And the prototype keyword is the way that you access the superclass. Okay? It's not exactly how it works in JavaScript, but if you come from the Java world, you understand what superclass means. And essentially, the prototype is a way of getting to that superclass. All right? So we have this all defined now. We have our gadget object. We're going to new up some new gadgets, an iPod and an iPad. And then I'm also going to go and set gadget.prototype.describe. Right? And you can see from this that I have it defined in two places. Once in the class itself, and then directly against the prototype object. So what do you think is going to happen on line 15 when I run console.log gadget.describe? Will I get the price or the color printed out? Okay. We have a couple of votes for price. Price? You sure? You guys want to bet 100 rupees on that? No? All right. So let's go run this, and we'll see what actually gets printed out is a big nasty error. That's great. Oh, yeah. Sorry. Updated the code. Let's try this again. All right, there we go. So we actually get the color printed out. Now, why is that? The reason is just like in Java, if you have a local version of that property, or that property named locally, that is the property that gets referenced. So if we wanted to get the price out, if we wanted to use the second describe function, which is in the prototype, what we would need to do is we would need to get rid of this. So if I comment this out, and if you watch the output, that will change from color blue to price. Okay? So just like you would expect in Java, if something exists in this class, that's what you get. If it doesn't exist, it starts walking up the inheritance chain and says, hey, do you have this? It asks the parent, do you have a describe function? And in this case, the parent has the describe function, so that's returned and that's what we execute. All right, so let's play around with this a little bit more. So again, you think of the prototype as the superclass. Let's play around with this a little bit more and run a couple of other things really quickly. If we take this and put it back in, and let's run a couple of different things here. All right, so one thing that I did is here on line number 11, I directly accessed the prototype, again the superclass, and I just affixed an arbitrary property to it with the value of 100 and name of price. So that prototype object is basically just an object. Right? So what happens in JavaScript is when we new up something, we're using this function literal syntax to essentially create what we would call a class in JavaScript. It's not really a class, it's a function. Again, this is JavaScript, not Java, but you can think of it like a class when we use it in this specific way, where we use function literal syntax to create this gadget with a capital G, and then we use the new operator against a function, right? So when we run this, what happens is we get a copy of all this stuff that's in this gadget. We new it up, we get a new instance of it, and the internals of it, obviously, it's like having a copy. It's just like Java, where when you create an instance from a class, you get an object, a real object that you can use and do stuff with, okay? But we also have this prototype here, and the prototype, again, is a superclass, and it's just an object. If you don't set the prototype to be anything, when you new up an object, it basically gives you just a blank object. So this prototype is essentially a blank object. And we can prove this by going into here and selecting gadget.prototype and doing console.log gadget.prototype. And when we run this, you'll see right here, what's the first thing we have? That's the first thing we're printing out. We basically have an empty object literal, i.e. we just have an empty object. Right now, if I move this below this second line of gadget.prototype.price and run this, you'll see now we basically have created an arbitrary property inside of that object. Okay? Does this make sense so far? This is pretty straightforward, right? So let's get rid of this stuff and back out some of our changes. Now, if we go and run this, you'll see we're both getting the describe and the price here. Let's try a couple of more things here quickly. We have, hold on just a second. What we want to do here is try something like this. Let's say that we actually want to go and get that describe out of the prototype, i.e. the superclass. How do you do this in Java? How do you go and get something that may be in the superclass when you're in the Java class? I don't remember, so you have to answer for me. It's been a while since I've done Java. How do you do that? Right, you do super dot and that goes and gets it. So maybe JavaScript allows us to do that. Let's go run this and let's see what happens. All right, so we're going to go run this, and this will be the last console.log we have printed out, and we get an error. What's the error say? It says, cannot read property describe of undefined. So we actually hit upon a little nuance of JavaScript. When we set the gadget.prototype on line number 12, you can see we used a capital G and not this iPod, right, the instantiated value. So you can access the prototype directly using the prototype keyword, but only against the function literal, not against an instantiated version of that object. And of course, this is JavaScript, and of course, in JavaScript, everything is available to you and open, and that is both dangerous and sometimes useful. So when you see some JavaScript code that has something like what we have on line number 18, that underscore, underscore, proto, underscore, underscore, what we're doing is we're using what's supposed to be a hidden variable, hence it's got the underscores around it. So we can go do this now, And lo and behold, what we get is, we get a function. So you can see, it's not actually printed the whole thing out, but you can see it's gone and gotten that describe function. Instead of airing out and say, I don't know what you're talking about, it's got the describe. But to make this a little bit more clear, what we can do is instead of trying to get that describe function, I can just call this price, and I can go run this, and you can see there's the 100 again that we expect. Okay? So I'm not saying that you should use underscore proto to go and access something in the superclass, but if you're like me on a Saturday night, after you've got all your stuff done, what do? You go pull up, go find what the latest hot JavaScript framework is. You pull down the source code, and you crack open a beer and you start reading through the source code, right? Because that's fun. So if you see this in code bases, or if you look at like example projects out on GitHub or any open source project, now you understand what underscore proto means. It's essentially a way to access the prototype in an instantiated object. Okay? All right, so let's move on. We'll talk a little bit more about this later. But for now, let's move on to something a little bit more interesting. We've already done some of this, so we'll skip it. So let's kind of just review quickly. In JavaScript, objects are passed by reference, not copy. As you saw, prototype languages are live. That means you can make a change to an object at any given point in time whenever you want. JavaScript is an open and live language, and that means modifications on prototypes can be done at any time. And of course, you can change stuff even after it's been instantiated, right? There's no rigidity. So what I mean by that is I went in and I added a property to an object that had already been instantiated, right? Or any object. So in Java, can you say you have a person class? A person will have a name and, I don't know, let's say they'll have a name and a height. Can you go and add like an employer string to it after you define the class? No, you can't. But in JavaScript, objects are open at any given point in time to any kind of manipulation. And again, that can be both powerful but also very dangerous. All right, so a couple more things on objects. The quote-unquote object is the root of all objects in JavaScript. Basically, all non-primitives are objects. Okay? And you can enumerate all the properties in an object, and you get everything except for the built-ins like constructor, length. And one way that you can find out if a property belongs to that specific object or is in a prototype is by using hasOwnProperty or property is enumerable. All right. So I'm not going to go over this example. This is pretty straightforward. But I do want to cover some JavaScript basics next. So the basic unit in JavaScript, I think of two basic units in JavaScript. You have objects, and you also have functions. Functions are first class. So those are the two basic building blocks in JavaScript. In Java, you only have one building block, and those are objects. You don't really have this notion of functions. Well, of course, they have Java 8 out now, so you do have this kind of notion of functional programming and functions as data. But in JavaScript, you have two base building blocks, as opposed to just one in Java. You have functions as building blocks, as well as objects in building blocks. Right? And objects are a little bit overloaded. Functions are a little bit overloaded. As you saw in the last example, what we did was we used the function keyword in function literal syntax to go and create new instances of an object. But obviously in JavaScript, functions are also used for what we think of as method invocations. So you can execute a function as well. Okay? And functions are also variadic in nature and always have been in JavaScript. Variadics were introduced, I think, in Java 5, which is you can pass an arbitrary number of parameters into a function and go get those parameters. And also, in JavaScript, you can also have anonymous functions. And we'll actually use some anonymous functions in a bit. And you guys have probably all used anonymous functions. So we'll talk about that in just a second. But let's do a quick variadic example. Okay? So let's go into our code, which is up here. Okay, and let's pull up our example. And actually, what I'm going to do is I'm going to rewrite this. Actually, let's do this. Let's just start right from here. All right? So here we have a simple sum function. First, we define it as sum x comma y, return x plus y. And the variadic nature of JavaScript is in the highlighted keyword, in arguments. Whenever you invoke any function, something that's just there is the argument's object. Right? We'll print that out in just a second so you can see it. But let's go run this and make sure it works first. So let me just copy this sum right here, execution, and we'll need to log that out. So let's wrap that around a console.log. Okay, and we'll run it 2 times. All right, so when I run this, you can see I just left the 1, 2, 3 in the first call, even though we're only binding 2 formal named parameters, x and y, on the first line. When I run this, what results should I get? What are the 2 numbers that should get printed out? What's that? 3 and 6? Does everyone agree? Okay. So anyone want to bet 100 rupees that is not what will happen here? Look at this code. It's pretty simple code, right? What's actually going to happen when I run this? You sure it's going to be a 3 and a 6? Maybe we'll get a 15 and a 10. I don't know. I'm asking you. We're going to figure this out, right? What do you think? Look at the code. It's really simple code, right? I mean, you guys should be able to read this in 5 seconds and figure out what it does. You think we'll return a 2? That's not a bad answer, actually. All right, so let's go run this, and we actually get a 6 and a 6. Now, why would we get that? What's going on here? Remember, JavaScript is an interpreted language, right? So what's going on here? Anyone want to take a guess? There's an obvious answer here as to what's going on, but what do you think it is? That's actually what's happening. So the comment was that we're actually experiencing something called hoisting. So what happens in JavaScript is that there's this concept of hoisting. So one of the things that JavaScript does is when we have any variable, in this case, remember, functions are data just like anything else in JavaScript, right? A function, and we'll talk more about functions, but functions are like any other bit of data, any other variable we have. So what happens is during the parse phase, JavaScript rewrites this code like this. It puts var sum at the top because we've defined a function called sum within that scope. So it takes that and moves it to the top, all right? And as we interpret this from top to bottom, it gets redefined and then executed. So again, you have to remember that JavaScript is an interpreted language. So it has 2 distinct phases when you execute a JavaScript program like this. The first phase is a parse phase. It looks at all the characters we've typed in this program and essentially builds out an abstract syntax tree. Then gets handed over to an executor to actually execute. Okay? So in the parse phase, it rewrites the code like this. It starts parsing it from top to bottom. It gets to line number 2 and says, oh, you're defining a sum. It creates an abstract syntax tree around it and assigns the sum, the variable sum, to be the representation of that AST for the implementation. Then it gets down to line number 4 and says, oh, you're defining sum. I see why you defined it, but that's okay. I'm not going to complain. I'm just going to keep going. And it will reassign the value of sum to the new value that we have on line number 4. Okay? And part of the reason why this happens is because of hoisting. Again, we take any variables that we have in scope, and they get moved to the top of that specific scope. So say, for example, I came down here, and I did var x equals 100. When JavaScript starts parsing this and building an AST, one of the first things it does is it takes that var out, and it does this. Okay? So you have to be careful about this. And this is why when you see some JavaScript code bases, right, if you look at the samples of how people are writing JavaScript, one of the things that people do is to avoid hoisting problems like this, they will actually declare all the variables that are going to be used in that scope at the top of the scope. I'll show you what I mean. Right? I've actually done this. You can see right here, I declared var I and x, and actually even initialized x to be something. But one of the things people will do is they will literally say, okay, as they're writing the code, they say, oh, you know what? They'll be down here saying, oh, I need a new variable called y. So they'll come to the top of that scope and say, all right, I'm going to hoist that variable y to the top, and then say y equals 1,000 or whatever. Okay? So this is the concept of hoisting, and this is, I don't know if you would call this a best practice, but this is something that people do routinely, is they go ahead and move stuff and declare it at the top so that they avoid any problems with hoisting. All right, so the next question equals function x and y, okay? And then we would similarly do the same thing here. Okay? So now when we run this, what do you think we'll get? I've already told you the answer. We'll get a 3 and a 6 like we expected originally. All right? So why does this work versus the first example we showed, which didn't work? The reason why this works is when we did it the first way, it was not on the right side of an assignment operator. That will be. We don't. We have to run all the codes before it, and when we hit line number 14, that will be the values that are available at that point in time, and then it will get assigned to Z. So anything on the right side of an operator is something that can only be done at execution, right? Because if you look at this, you don't know what X and Y are definitively until you get to that point in time. I may be doing something off to the side that changes the value of X before I get to here. All right? And this is actually, if you have studied computer science, this is an example of the Turing principle. Right? So the Turing principle is that all computer programs adhere to this one principle where you have a piece of tape, and things that you can do in a program are based on a pointer that you have on this piece of tape that can only go back and forth, i.e., no way that you can mathematically predict what X and Y will be at a point in time until you get to that point and actually execute it. All right. So we've done that example. Let's go to the next one. Talk about anonymous functions really quickly. So anonymous functions, you guys have probably all done this. If you use jQuery or anything, any common way to write programs in JavaScript, you'll have some kind of element and you want to attach an event listener so when it clicks it, go and run this, right? So what we have on the first line here is essentially an anonymous function call, right? No big deal. Now, what we tend to do in code base nowadays is we try not to use as many anonymous functions inside event handlers or any kind of callback. What we prefer to do is what's in the second block, right? So both these blocks of code are equivalent. They will work exactly the same. The only difference here is that the second one, even though it's a little bit more verbose, is a little bit clearer. When I go look at that very last line of code, append.addEventList, click, print append, it's just one line of code. It's fairly straightforward. If I need to see what that print append is, it'll be somewhere in our code base and I can go look it up. As you can see here, it's just right above it. This is a very simple example. We're printing something to the log. But imagine if you have an XHR call where you get some data back. If it's successful, you go and do all this stuff with the data, right? So for clarity, we'd like to, this is just a style kind of thing. There's not one way is not correct over the other. It's a style kind of thing. We prefer to do things like this as much as possible because it just makes the code clear. The other thing is, in this case, this print append becomes something that is reusable. So I can use it here or I can use it somewhere else. And I've created a named function that I can use in multiple places if I want. And as the gentleman in the front mentioned, another way that this is useful is that now my non-anonymous function, i.e. my name function, is something that can be used in a unit or functional test of some kind. Right? So you don't have to write a mock for it. You have the function there. You can just insert it in a test if you want. All right, it's quiz time again. Which one of these are objects? Var speakers equals an array. Var topics equals a literal. Var foo equals new object. I'll give you a hint. The third one is an object. All of them are objects. Good. So in JavaScript, you have to remember, everything is an object except for primitives. So I think in other languages, sometimes arrays are modeled as not objects, but basically a special primitive type. But in JavaScript, everything is an object. And on the first line where we have the square brackets, var speakers equals that. The square brackets are just a shorthand annotation for new array with these parameters. Okay? We'll actually build on that a little bit in a while. All right. So let's go to our next live coding example. And let's actually clear this out and start from scratch again. Right? So we're going to do console.log on this. We set foo1 up here, and then we say var foo equals 10 down here. We log this out inside, and let's also log it out on the outside. What results should I get when I run this? And note, obviously, on line number 8, calling bar, which is the function just above it, where I console.log the value of foo. What do you think the two things will get, what are the two values that will get printed out? Should we get a 110, 10-1, 1, or 10-10? What do you think? 1, okay. That's interesting. 10-1. All right, let's try this. So some people did have the right answer. If we run this, you'll see we get a 10 and a 1. Because we're executing bar, on the inside of that we have a console.log on foo, and then obviously on the outside we have console.log foo. Now, the reason why we don't have a collision between those two variables is because we have that second foo inside the function. There's only one way in JavaScript to create a new scope, and that is by writing a function, right? So we've given that thing some scope safety. If we come back to this code, first thing you should notice is, why does this even work? Why is it not of undefined true? And that's because of hoisting. Again, what happens in this case is this var foo here gets rewritten like this. Okay? And you have to remember, hoisting happens within a scope. So that var foo gets hoisted to the top of that scope. A function is a way to create a scope, so it goes hoist to the top of that function, not to the entire program, right? So if we create another variable down here called var x equals 100, this would get rewritten in hoisting like this. And then similarly, if we came down here and did var y equals 1000, this would get written like this. Okay. But anyways, we already talked about hoisting, so I don't want to talk too much about it. Let's go back down here and explore what exactly is going on when we hoist. So when we do this, the opposite of undefined in JavaScript is true. That's why foo gets set to 10. Okay? All right. So that's specifically in the scope, what we wanted to verify your understanding of was, how do scopes get created, and what's the region of the scope? And we've seen that the region of the scope is inside the function, and we've done variations of some of these already. So one thing that we could do, or one thing that you may see, is see that for whatever reason, I needed to have another variable called foo inside of this application. Okay? So let's say that we needed to have, let's take this console.log, and let's say we needed a foo there, and we need another foo here, and this one needed to be set to 42. Okay? But we wanted this to be a brand new variable that doesn't affect the previous variable. What we need to do is create what's called an immediately invoked function call. And what that looks like is something like this. So we would take this code here. Right, we would write it like this. Right, so if we go run this, there we go. If we go run this, you can see that our foo is set to 42. You can see it's the second thing that's printed out. Let's take this out for now, so we don't confuse ourselves. And let's actually add another console.log at the end of this. Okay? This is a complete example. So whenever I go run this, you see we get on line number 7, the value of foo is 10. And then on line number 10, the value of foo is 42. But when we come out of that block, the value of foo, again, is 10. So what we've done is, again, the only way to create scope in JavaScript is by creating a function. So a common technique that JavaScript developers use is what I have on this example in the middle, which is what's known as an IIFC, an immediately invoked function call. That's what the syntax is about. We have a parentheses at the beginning of this line, number 8, and you can see the matching parentheses is right here, and then immediately after that we have an open close parens. When we have an open close parens like that, what does that mean? That means invoke a function, right? So what we've done is we've created an anonymous function here in the middle, and we immediately invoke it. And the only reason for having this kind of syntax is so that we create a new function scope that gives us the ability to give us encapsulation and scope safety. And this is a very common technique in the JavaScript world. It's called an immediately invoked function call, or sometimes also known as an IIFE, an immediately invoked function execution. And the whole reason for this is to get a new scope, to get scope safety. All right, so let's move on and talk about some more stuff. We've done the scope stuff now. And let's quickly review some scoping rules. We only have function level scope. Within that function scope, we get this and the arguments keyword. We also get the named parameters and the function declarations and other things we have inside of it. Okay? So in JavaScript, we need to learn new techniques if we're Java developers. We can't use the same old techniques that we have. So let's spend a few minutes talking about some techniques. I'm going to skip over parasitic inheritance for now because we don't have a lot of time. If we have time, we'll come back to it. But let's talk about some common techniques. Right? So the first one I want to talk about is callbacks. So you guys are all familiar with callbacks because you probably have written code where you pass something a callback. But you don't have to be limited to just what's available. You can create your own callbacks. And here's an example of something that you can write in a callback kind of style. Say you needed to execute something with a random number. So I created a new function called execRandom. So I could just call execRandom, get a number, and then pass it to something, and that will execute it, right? But what I want to do in this case is I want to have an execRandom. I say, as you can see on the sixth line down, when I actually invoke it, I say, give me a number between 5 and 15, and once you have that calculated, that random number, go and run this thing. And the reason why we can do this is because in JavaScript, functions are first class. You can pass them in as a parameter to something else, and that's what we're doing there. We do execRandom, 5, 15, function. In this case, we're just passing in an inline anonymous function, but you can see what happens is that on the first line, that gets assigned to the value callback, and then after we've computed the number on line number 4, it essentially takes that function that we have passed in as an argument, as a parameter, into this other function, and then actually goes and invokes it. Okay? All right, so now that we've talked about callbacks, we can talk about closures. So I'm sure you've seen a lot of discussion on closures. Closures have been supported in JavaScript for forever, basically, since the beginning. But the second bullet is key here. A closure is essentially a way of presetting a context, or it's a way of setting local variables for a function that are kept alive even after the function has returned. It's a way of presetting some values. The value can be, in this case, in a closure, the value is going to be in the function. And you know you have a closure if you have a function keyword inside another function. So let's go look at a closure really quickly. This is the simplest implementation of a closure I could come up with. We have a sayHello function. And what the sayHello function actually returns is another function. Again, remember, JavaScript is a functional programming language. You can take a function, pass it in as a parameter to a function. You can execute a function, and instead of returning a value like a string, you can have a function return another function. So that's what's happening here. We call sayHello. It sets the value that we passed in this case, the name, on the second line. We use that name value somewhere in a new function definition, i.e. we're presetting a value in a new function that we create. So we're actually creating a new function. We're kind of like having a program write a program. Okay? So, and then we actually return the function and not the text, and then at some arbitrary point in the future, we can execute that hello function. It doesn't have to be on the next line. It could be, we could define it here, and we could execute it way down here. Or we could execute it multiple times. Okay? And this is some of the power of closures. I'm sure you guys have been to some of the other sessions this week that talked about functional programming, and I would be surprised if they did not talk at length about closures. Closures have always been in JavaScript. All right? So I've already talked about this next technique, which is creating temporary scopes using an IIFC, an immediately invoked function call. So I'm going to talk about this again. Let's talk about comparisons for a few minutes. This is always a lot of fun. In JavaScript, comparisons can be a little tricky. So we have, on the first line, we have the empty string is equal to the string 0. But 0 is not equal to empty. I'm sorry. The first one is false. The second one is true, where 0 equals an empty string, equals an empty string. 0 also equals the string 0, but 0 equals the string 0 is false. Okay, and once we start getting into using booleans like true and false and null and undefined, everything goes a little crazy. All right, it can be difficult to, it's like, what's going on here? All right, WTF, as they say. But if you remember one important rule, that is always use triple equals. You will be fine. Okay? We rarely use double equals in our code base. There's actually very few cases where you need to use a double equals. What a double equals actually does in JavaScript is that it does type coercion. So it looks at the thing on the right, it looks at the thing on the left of the double equals, and makes them the same type, and then does a comparison. Okay? It does type coercion. Whereas with the triple equals, it first checks to see if they're the same type. If they're not, sorry, it's false. Right out of the gate. There are very few cases where you need to use a double equals. In fact, when there are cases when we need to say, hey, is an empty string true or false, we actually will go and manually change the type or change the thing that we're comparing to be of the same type and then do a comparison, just so we avoid issues with using double equals, right? It's a little protection, if you will, against some of the edge cases that you get with using double equals versus triple equals. So with that in mind, let's go run this really quickly. All right? It's quiz time again. So let's say we have var c equals the array 1, 2, 3, and var d equals the array 1, 2, 3. All right? Or it could be an object. What is going to happen on line numbers 7 and 8? Are we going to get true, false, true, true, false, true, or false, false? What do you think? True, false? Okay, that's a good guess. Anybody else? Okay, so we've had most people are kind of agreeing on true, false. Well, this is not the case, unfortunately. You can probably guess what it will be since I've said that that's not the case. We actually get a false and a false. Does anyone know why we get a false and false? In JavaScript, you cannot compare objects. You can only compare primitives. The double equals will compare things. So you can see on line number 11, I assigned E equals to C, and then I did a comparison between those two objects, E and C. You have to remember, in JavaScript, an array is an object. You cannot compare objects in JavaScript out of the box with the double equals or even a triple equals. How do you compare two objects in Java? What do? Right, you override the equals method, right? So that's how you compare objects in Java. You have to literally, if you have two objects, you have to implement the equals method, and then you can compare them. Sorry, in JavaScript, there's no such way to do that. So what you actually have to do is you either have to do manually a deep comparison of all the properties in an object, or you use a library like underscore to help you do something like, to do object comparisons. And again, you have to use a utility library to allow you to do object comparisons. Okay? All right. So let's talk about JavaScript modules for a minute. Building a large JavaScript code base can be a pain. There is an emerging standard that's used in Node.js called CommonJS for creating essentially modules, but this is not something that's supported in browsers. Okay? The point of CommonJS and modular JavaScript is to provide encapsulation and reuse. Right? And I'm not going to talk about the CommonJS node.js example, but what I do want to quickly show is we're going to use some of the things that we've already done, and I apologize to the folks that were in the session yesterday when we talked about the module pattern. But what we do in JavaScript is we implement what's called the module pattern. It's a design pattern. It's not something that's supported by the language. It's something that JavaScript developers like us have come up with to help us organize JavaScript code base. So what we do, and this is specifically an implementation of what's called a revealing module pattern. The first thing we do first technique we're going to employ here is the immediately invoked function call. You saw this a few minutes ago. Why do we use the immediately invoked function call? To get scope safety. Okay? So you can see here's the top of our IIFC, and here's the bottom of it. Right? So here's the end of that anonymous function, and here's the immediate invocation of it. Now inside of this, I have liberty to call my variables whatever I want, because they're not going to pollute the global scope, and more importantly, things which are in the enclosing scope will not pollute what's inside of here. So username is a great example, right? Because it's very possible that on the outside of this, I may have a variable called username, right, that's set to something. This username will not pollute this other one because it's an IIFC, okay? But the way we think of modules in JavaScript is that it's not like a class in Java. A class is kind of low level down here. It's very fine-grained. A module in JavaScript is something that is coarse-grained, slightly higher level. I think of a module more like an API, a unit for an API, putting stuff in an API rather than a class level, which is very, very low level. Okay, so it's slightly higher level, it's coarse level kind of thing. And what we do is we define some stuff. Like here, I have function login, I have logout internal, I have get username, and then what I do in the return block is I create a new object literal. And again, this is specifically the revealing module pattern. And I give key value pairs, login, logout, get username, etc. And what this does is, this is specifically what I'm exposing outside of this module. So this is the user service module. And, right, so here's my user service. I'm assigning it the result of this immediately invoked function call, which will be this return statement. I create a new object literal here. Okay, and I map the keys in this new object literal to values that are inside of this module. And this is great in a couple of ways. We get the encapsulation. The other thing is if I haven't written this user service and the developer who wrote it didn't leave me any documentation, I can just go to the end of that user service, look at the return statement, and say, aha, this user service exposes a logout, a login, and a get username. Right? And that's how I know what the quote-unquote API for this specific service is. So this is what we call an organizational pattern. It helps us organize our code base in a nicer way. All right, so let's actually run this code and make sure it works. So let's go up here. We have our user service. When I log in, it should say user logged in with whatever, and when we log out, it just nulls it out. So let's go run this really quickly. We're going to log in the user, and then we'll go get the username. So when we run this, you'll see that we get user logged in with Pratik, and then I can do user service.get username to get that logged in user value. Okay? All right. So let's push on. And I do want to mention UnderscoreJS very quickly. If you're not using UnderscoreJS, you should probably look at using it, or one of its other one of the other libraries which are similar to UnderscoreJS. Another one that's getting popular in the community right now as a replacement for UnderscoreJS is called Lodash, L-O-D-A-S-H. But the idea with Underscore is that it gives you utilities for working with data collections and various other things within your code base. I have some examples on here. For example, if you wanted to iterate over an array, you would do underscore.each, 1, 2, 3, and then pass it a callback function that would get operated on for each of the things inside of that array. And UnderscoreJS is somewhat functional in nature, so it has things like map and filters and other things. So you can see the second example is map all the values in this array against this callback function, or use the callback function and map it against all the values in the array. Okay? All right. So another thing, this has gone totally messed up for some reason. It's actually, nope, this is date.js, not moment.js. All right. So another very useful library is date.js. There's actually something that's newer called moment.js that we've been starting to switch to. But date.js is essentially a way of working with dates in JavaScript. Right? It makes working with dates much more pleasant. It supports UTC and various other things like that. But you can literally do date.today next Thursday, and that will return you a date object that represents next Thursday. Okay? And you can do date.today.add 3 days, and that will give you a date object for 3 days from now. right? And you can also parse dates, and you can also format dates for printing out. Okay, this is an invaluable library in our toolkit. All right, so let's look at a few more things real quickly. So what we want to do is, let's go back to some of our code examples. Okay, and let's look at a couple of different things quickly. See if I can find the right one. All right, so remember I said that JavaScript is an open language. You can manipulate anything in JavaScript at any given point in time. Well, guess what? You can also manipulate things, objects that are built into JavaScript, such as the array object. So the array object doesn't come with a function called give me the maximum value inside of this array. I called it max size here, right? Let's change this to max value, right? So what we want to do is we want to write a function that goes and looks at all the things which are in the array and gives us the maximum value. That is not something that's built in, but we can literally do array.prototype.maxValue and create something brand new that is in the basically a brand new function inside of the array. So this will actually work. All right, so when I run this, let's do this first. Let's make this break first. So I'll do var.maxValue and try to invoke that up there. Actually, let me just copy this whole line. Okay? And let's go run this, and we get a big fat error. It says, what do you mean? I have no idea what this max value is here. And that's obviously up here on this line because we haven't defined it yet. We haven't actually gone in and manipulated the built-in array object. So let's take this out, and we're going to go run this something function to add max value function to the array object. So now when we run this, you can see I haven't actually implemented it. I just have it returning 42. Okay? But you get the idea. Objects in JavaScript are open at any given point in time. You can do anything you want. Okay? This is going to be both very powerful and very dangerous. In fact, in the previous example I just showed of date.js, right, if we look at date.js and we look at, and this is real code, JavaScript has a date object inside of it. So how the hell does it have date.today? How does it have, because that's not built into the date object, right? So, and doesn't have date.parse. Actually, it may have date.parse. But what date.js does is when you load date.js into your JavaScript context, it actually takes the built-in date object and adds a bunch of stuff to it. It adds date.today and date.parse and date.format and date.set and blah, blah, blah. It essentially goes and manipulates the built-in date object to add all this extra functionality. Yes, please. Okay, so the question was, what's the difference between one of the examples I did earlier, where I used underscore proto, right? That was in the first example. Let me go find it real quick, right? So where I basically did iPod.__ proto. So when you create an object, when you basically instantiate an object using the new keyword, right? So in this example, we did new gadget. That creates an instance object. And the only way to get to the prototype from the outside to that instance object's prototype is by using __ proto. If you're just working with, let's say, the template class, right, i.e. the function gadget, capital G gadget right here, right, because it's not an instance object, I can do gadget.prototype and get to that specific template class's prototype, okay? But in this case down here, when we do iPod, well, once we've instantiated it, we can't directly access the prototype. You can obviously, inside of the gadget, you can obviously access the prototype. I don't remember exactly what the syntax is. I think you can do this. I think it looks something like this. I have to think about it for a second. But it's something like this. You can just go and get the prototype directly like this. And I don't think this is 100% correct. But on the inside of that object, you can use the prototype keyword. But we're on the outside. We're not within the object itself. We're trying to access something from outside inside the object, and because it's an instance, we have to do it like this. Okay? All right. More questions? We still have a few minutes for questions, so yes? Yeah, that's a good point, actually. We have a few minutes, so let's cover parasitic inheritance really quickly. So parasitic inheritance is, and actually I think I just have a code example I can show you. You can actually play around with it a little bit. Okay? So here's an example of parasitic inheritance. Right? So we have a shape object. We want that shape object to have a couple of, again, we think of the shape being the supertype. Right? We want to have a name, and we want to have a printout name function inside of it. Now we want to create a class based on the shape superclass called rectangle. That's what we have. That is what we have on line number 7. Okay, and the rectangle will have a width and a height. And I'll go run this really quickly, just so you can see that this works. This is rectangle of size 100, and we're going to call the instantiated rectangle's printout name. And you can see it indeed works as we expected, because we set the rectangle's name down here. Now the reason why this is parasitic inheritance is that what we do when we run this is we're essentially creating a parasite, or something for properties to latch onto. So the way this works is we create a blank function with a constructor. Right? So we do var p equals empty function. We immediately go and set the prototype of that new template class to be shape. Right? So from the syntax highlighting, you can see that's shape. Then we go new up one of those, so we get an instance of it. And then once we have an instance of it, within this rectangle constructor, if you will, we go and set the width and the height to be the passed-in width and height. And we also set a built-in property, or what we consider to be a built-in, to be the name, i.e. a hard-coded property to be rectangle, right? And the reason why this is specifically called parasitic inheritance is because of the lines I've highlighted. What we do is we just create a blank object, and then we attach stuff to it, and we new up an instance of it, and that is essentially the model known as parasitic inheritance in JavaScript, right? That's different than straight inheritance and basic inheritance in JavaScript. Okay? All right, so more questions? I think we still have about a minute left before we need to wrap up. In working code? Yeah, but, actually, we should just be able to take this closure example. We should just be able to take this and directly run it. So let's go try that real quick. Let me get a blank file to run this in. Okay. So let's see what happens when we run this. This will break because alert is not defined. So we'll do console.log, and we'll go run that. You can see that that actually does work. So again, the whole point of this, when we talk about closures, is we want to think of it as a way of presetting some data or presetting a function. Because again, functions are just data in JavaScript, right? You can take a function, pass it in as a parameter to another function, and or have a function execution return a new function. And that's what we're doing here. We pass it in some basic data. Here's the name. You can see from the syntax highlighting that we assign it to this new string called text. That text is used to compose this new function. All right, so let's clean this up. So we essentially create a new function called sayAlert inside of this sayHello, and then we actually pass that function back. So that's why when we get down here, we have to do hello, open, close parens to actually get the value out. If I just take those out, you'll see nothing happens because we haven't actually executed the function. So we get that function. Again, the important part here is that once I've called this hello, once I've created this hello in this specific way with this specific data, i.e. the name, I've just passed in my name, Pratik, inside of it, right? And I can call hello then. Or I can call this new function which had a closure 3 times if I want, right? Or I can wait some time and call elsewhere. I can go do a bunch of stuff, and then I can call it over here if I want. Okay? All right, well, thank you for coming. I think we're out of time, so I hope you enjoy the rest of the gigs. And if you have any questions, I'll be around for a few minutes down here. All right, thank you, everybody.